Remind me that I need to hand back your tests today, and to talk about them. And the homework tonight is technically the Delta Math again. Like if you didn't finish it yesterday, it's the same thing. If you finished it yesterday, you have no homework tonight. We're going to start the last section of chapter 4, which is related rates. And some of you react to related rates kind of like optimization. I endeavor to make you not hate it that much. Yay? Yay? Nico, what was your opinion of related rates?
Oh, I forget.
Nick?
I don't think it's as hard as optimization.
Okay, that's a decent answer. Okay. So Eddie, did you? I heard you guys talking about the warm up. How would I do?
I mean, I just got dy dx. I don't know where to go from there.
Okay, well, if it was just implicit differentiation with respect to x to y, then the derivative of y with respect to x equals 2x times the derivative of x with respect to x, which is dx, which is just 1, so I'm not going to write it down. How would it be different if I did it with respect to t? Multiply by the power, lower the power, and then what's the derivative of y with respect to t?
dy over dt.
dy dt. And this one, power rule, multiply by the power, lower the power, the derivative of x with respect to t, dx dt, right? That's it. So, Alessandra, yeah? What was the point? What's the point? Okay, all right. We have an attempt at, what's the point of that? Here, you can hand out these. Yeah. And we can hand out these. Yay. You can hand out these. We can do just one sheet and one thing per pair of people. So, all right. I've not done this experiment, but this morning is hit or miss. So you're all gonna get a grid like this, and we're gonna see how things change with respect to time. All right. All right. So I believe your grid is 20 squares long. Sure. Thanks. Yeah, I think it is. So we're gonna have this is a car, and it's driving towards this intersection. Let's say, for excitement's sake, it's a cop car, and it's chasing after the Batty Bear car. Carmen, where should we make the Batty Bear car start down here? Like how far over? 7. Okay. And the Batty Bear car is trying to go away. So A is starting at 20 blocks above my intersection, and B is starting 7 blocks to the right. So just so that we can do a few iterations, well, how fast is my cop car moving? How many blocks per second? 1, 2, or 3? Not 5. 3? Okay. So we're going to say the cop car is moving 3 blocks per second. How fast is the Baggy Bear car moving?
5.
Okay. Okay. So, yes, Chris.
Does it matter as of right now that it's like 20 and 7 when it's like different ways? Like when is 20 out?
Okay, no, because let's check on your thing, how big is each block? On, like, measure it with a ruler in centimeters. 1 centimeter, okay. So this car A is 20 centimeters up and car B is 7 centimeters to the right. And we're gonna say these red lines are the roads that they have to drive on, and the stuff in between is not drivable. So I want you guys to take your ruler and measure with a straight line. What is the distance between A and B? First period, we got a lot of different numbers and everybody should have had the same thing, so I'm a little.
19.5 centimeters.
19.5 centimeters, 21, those are big differences.
Oh, did they? It's supposed to be. Is it supposed to be all the way in the corner or 2 down?
All the way in the corner. Is this supposed to be? It's supposed to be
Sorry, yours is all the way in the corner. My grid is actually a little taller than yours. So, sorry guys, so 20, you guys got what? 21? Ty, would you guys get 21?
19.3.
Fine.
So, guys, my grid is 2 blocks higher, so if you started yours 2 blocks down, that might be the issue. So, sorry, you guys, those of you that I see that have it marked correctly, Leo, you guys get 21? Okay. So at the start, A is at 20, B is at 7, and the length between them is 21. All right, time is changing. 1 second later, Colin, where is A gonna end up?
He's gonna be at 17.
17, okay? Ellie, where is B gonna end up?
15? Oh, sorry.
Okay, so we randomly chose Adney's stuck on like it's moving 5 blocks per centimeter or second. So B is screaming away this way, 5 blocks, so it's gonna end up being, starting at 7, it went 5 blocks away, so it's at 12.
12.
So now measure it again.
It's like a little.
That's it. Got 21 again?
Yeah.
Do you guys agree? Is it 21 again?
21.5.
21.5?
It's just 21.
21.
21.5 or 21, it matters.
I got 21.
Okay. Loud, more loud was the 21. Okay. All right. 2 seconds.
22.
In 2 seconds, where is A gonna be? 14. Where is B gonna be? 17. And you measured it already? What is it? 22. We got 22 up here. Did you guys get something different? You guys agree 22?
22.
I'd agree, so, okay. Okay, so it is changing. Okay, do 2 more measurements.
Yeah.
So what, 3 seconds, what do you guys get? Any agreement on that? one group says this one's at 3 seconds, C is 24.5.
Yeah, 24.5.
Any measurement on the last one yet? 28?
Yeah.
Okay, so what's the point of all this? Hopefully this will make some sense. It sort of helped in first period. Okay, so looking at this. First of all, just the triangle, if I was chopper overhead, snapshotting this car chase through things, what common math equation would tie together these three lengths? Pythagorean theorem. So the distance of A squared plus the distance of the Batty Bear car squared and C squared. If I was to do, like, it's not a snapshot anymore, everything was actually moving. So the derivative 2A times how is A changing over time plus 2B, how is B changing over time. So, and everyone's rate of change was different. Car A, we had them moving at 3 blocks per second, and car B was 5 blocks per second. And C, the change in C seems kind of random. It didn't change in our first thing at all. Can I divide everybody by 2 right now just to make the numbers smaller? Because 2 is everywhere. Okay, so dividing by 2. So at the start, the very, very start, if I want to know what's the rate of change of what is dc dt, do I know what A is at the start? What was it? 20. And what did we, what did we choose as the change in A? 3. But here's the question. Something's wrong. I need to do something to that rate of change. Is A getting bigger or is A getting smaller? So A isn't 3, dt isn't 3, it's -3. Do I know B from the start? 7. And the change in B, 5, is it positive or negative? Positive. And what did we calculate CS to start? 21. All right. So you can use a calculator. What do we get for this? Or decimals?
1.19.
I got negative.
Yeah. 047.
So -1.19047. So at that immediately, like right from the start, that's how the distance between them was changing. The cop car was gaining on them by 1.1904 centimeters per second. But clearly stuff changed. The car is pulling away. So we could check these coordinates and say, well, at time 3, when it was 11 and 22, all right, let's try that. At time 3, what's going on? A was 11, and the change in A is still -3. B was 22, and its change is 5. C was 24.5. you guys get? 3.080. Really different numbers. What'd you guys get? 3.142, okay. So looking at this, 24.5 plus 3 and change, does it look like it was about right? So this is related rates, like, was it linear? Did the distance between them change in a predictable, just add 2, add 2, add 2? No, it's not linear. Is it exponential? No, we used calculus. How was this changing over time? We just calculated it. Austin? Question? No. Eddie?
How was the cop car gaining on it at the beginning if it started slower?
Well, because of the way the angle, I don't know, like the actual why, was it negative at that point? I don't know. It's just that dimension, it was more beneficial, but then very quickly, after 1 second,
Yeah.
that Lamborghini just took off. Okay, so this is related rates. So how is this changing over time? And everything has its own rate with respect to time, which, going back to this, well, I know how to do it with X. Does it make a little more sense now, like that X and Y can be changing over time and we can do all these rates together? All right. So today I actually have a sheet to hand out after we do this part. This is still the same warm-up. Oh, and what was the derivative of this with respect to t from the warm-up?
2y,
Equals what?
2x, dx over dt.
Okay, so this is asking you guys to find how is y changing with respect to time? Given dx dt is 2 and x is 1. Did anyone get an answer yet? What did you get?
dy dt is 1.
Y dt is 1. Does anybody agree? 1? Jack, can you show us the work that you did to get that?
Yeah, on the board.
Yep, on the board.
Sure. So. Oh, wait, I think
Sorry,
I just didn't know.
did your finger run out of ink?
No, I plugged in x squared plus 1 as y, but y squared.
Okay, well,
So
all right.
it doesn't-
So I don't know the y value
The
yet.
original equation, so you can solve for y. Plug that back in. Yeah,
Okay, I hear Eddie saying in the original equation that you were given, go back to the very, very beginning. Y equals 1 squared plus 1. So y squared equals 2. So you guys do know that 2 divided by root 2 ends up just being a root 2. And square rooting, I don't know, plus or minus. Do I have any context for this question? I might have both things. Kai?
How'd you get the top two equations up there?
Plug in 1 for x, because I need to know the y value. I was given an equation for y squared. So, yes.
Shouldn't the y be squared then and the y equals 1 squared plus 1?
I already did the square root. So yes. But, so here, I don't have any context for this. So I don't know if the negative thing makes sense or not, which, if you guys are solving for time, can we have negative time? Can the past happen? Yes, the past can happen. Like, so in these, it could be snapshot, we see the forest fires going over here, go backwards in time to say, where was the inception point? Where was the beginning? So you could get negative time, and it can make sense in a context. Sometimes it's, you solve for length, and you got a -3, and no, you can't have negative length. Can you have distance with a vector on it saying, go backwards 3 feet? Yes. So be careful about the context that they're asking you these questions in, because sometimes we throw them out and sometimes we don't.
How did you get the dy dx out of it?
It's dy dt. So dy dt is x over y dx dt. And the x value they gave us was 1. The y value that we calculated is plus or minus root 2. I don't know if they're both valid or not. And they told me dx dt is 2. So I think these questions are not so crazy hard because I need to tell you everything. I need to tell you how everything's moving except one of them and make you figure that one out. All right. So I have the notes on, and so that you didn't have to write down all the details. I have it on a worksheet for you. Okay, so real world context like thing, yes. And dividing by root 2. Did everybody get a worksheet or no? Did Kate get one? So everyone has one? Yes? Or has 18? You can, yeah. All right. So this thing is saying, all right, air is being blown into a spherical balloon that volume increases at 100 cubic centimeters per minute. How fast is the radius increasing when the diameter is 50 centimeters? So first off, have you all blown up a balloon sometime in your life? Like from flat, and you do the first puff and it goes, and it gets huge. The radius increases like huge amounts. And then second puff, not so much. Because your lungs have the same capacity. You do the same puff, but it's got to cover so much more space. It's got a bigger like ball of air that it needs to wrap around. So the radius is not changing as a constant, right? Like, can we agree with that? So this is going to be different. All right. So we need to pull out some information. And one thing, the only thing AP will give you is volumes formulas. So they'll be like, and of course you recall the volume of a sphere is 4/3 pi r cubed. They'll be like, oh yeah, you remember that, and they'll write it down for you. They don't give you anything else, but they give you that. All right, in the word problem, we need to be able to read stuff out of it. What information do they tell me?
dvdt.
dvdt is what?
100 cubic centimeters per minute.
And because these problems are slippery, is it increasing or decreasing? I'm gonna put a positive on there to say, I took note to say it's getting bigger. Because some of you are gonna write down, okay, the rate of change is, and not compute that it's actually getting smaller. Sophia, what else do I know? I know the radius. How do I know the radius?
The diameter.
Okay, diameter is 50, and by like understanding geometry, radius is half diameter. Jared, what am I looking for?
You're looking for how fast the radius is increasing.
So-
the derivative of rate.
So dr dt is what I'm looking for. Is there anything else I can pull out? I think that's it. So Arabella, what is the derivative of this stuff with respect to time?
3r squared times 4.
So you multiply by the power and lower the power.
Wait,
And-
you keep pi.
Why would it go away?
Oh, because it multiplies by.
It's just a constant. All of this mess is a constant. So multiply by the power, lower the power. But I'm doing the derivative with respect to time. So what else is floating around there? The r dt. Jack, what's on this side? dv dt. So the derivative of all those things, how is this changing over time? What do I know? What can I plug in? What is dv dt? What's the value? 100 over 4 times pi times 25 times 25. Okay, and the thing that, this is sort of self-checking. If you can read this to see that what you're looking for is dr dt, the mistake you guys make on these is you forget to do the dr dt, but if you don't do that, you've lost the variable that you're looking for. So it sort of should raise some flags to you like, problem, Houston, gotta fix this. What are my units? Chan, what are the units? Centimeters per time unit. What are my time units? So at that snapshot in time, it doesn't mean that the radius is changing at 1/25 pi centimeters per minute in the whole time of blowing up the balloon. It was just that split instant. Just like the car, when A is driving down and B is going forward, car A was gaining on them at first, and then car B just flew away. Okay? What do you think? All right. So these are the steps. They're written on the paper for you. If they didn't give you a picture, make a picture. If they didn't give you, if they gave you a big old story problem, pull all the information out. And then what were you looking for? That last one, we were looking for dr dt. And if we don't write it down and we forgot to list it, we might not ever know to go back and check our work. Find some equation to relate the variables. Sometimes that's obvious, like they gave you the volume formula. Sometimes it might be, well, they made a triangle with a right angle, so perhaps I need Pythagorean theorem. And then we're going to do the derivative of everybody with respect to time and then evaluate. So this one is just do the derivative. We're not plugging anything in, but do the derivative of everybody with respect to time. Yes, Adam.
Did you get 2 power?
When we dump water in or out of a cone, does the radius and the height change?
Yeah.
So they're both variables?
Yes.
So when I'm doing the derivative of this equation, do I do just product rule or quotient rule or power rule? Like, how do I do that derivative? Product rule, because there are two things that vary. Sam, what is the derivative using product rule? I did the hard part. dv dt equals
The derivative of the first part, you get 535 squared times 1 plus.
times. Okay, so first times the derivative of the second. What is the derivative of h with respect to time? dh dt. Plus second times the derivative of the first with respect to time. So what's that going to be?
2/3 r minus dh, or dr dt.
And that's it. So that's all this was asking you to do, was acknowledge and recognize that radius and height in a cone change. If this was a cylinder and you're dumping water in, does the radius and the height, do they both change? Radius doesn't change in a cylinder. In a cone, it does. Okay. So there's things you could clean up on this, but there's nothing you can do. I didn't give you any values. Cool? Questions? I do not believe we're going to finish this one, but I want you and your partner to work through and label some information. What is all the stuff that you know in this? Yes? Okay, so handing back the quizzes. Some of you did the famous mistake of reading the velocity graph as position, which is unfortunate. Wait.
So this would be the and then, so the elevation is
Which is
and then
the height at that and then 4.
I thought this was a position.
Oh, okay.
Yeah.
Brownie foods.
You're reading this as a position.
So then
Step 1, routine instruction. Step 2, routine instruction.
Yeah, that's step 2, gonna get you every time.
Equals text.
Absolute maximum initial challenge.
Okay, still handing some of these back. Comments on the test, yeah, if you read the graph wrong, yeah, see you for your requiz, because that's deadly. Let's see, other things, I warned you when I asked for the maximum or the minimum, I'm asking for the y value, and if you gave it as a coordinate, it is unclear if the coordinate, like, if you're like, oh, the maximum occurs at 2, 3. Is the maximum 2, or is the maximum 3, or is the maximum actually the coordinate? You lost half a point if you didn't specify the maximum is 3, because the AP exam will not give you anything. So be careful with that. And some of you in your wording still gave me if. It does this, or because the slope was positive. Slope of what? We had 3 different things going on. We had the first derivative, second derivative, and the original function. So is it f, is it f prime? What are we talking about? What else on here? Yeah, the slope of the slope, like what are we talking about? Some of you guys said that it's concave up because the slope of f prime or f double prime, like in your wording, you actually accidentally said f double prime rather than f prime. Gave funny things. Some of you on question 7 said, oh, well, this x value is not included, so the absolute max would have been there, but that it's not included, I'm going to pick this other thing that's a local max. If your function went like this, there is no local maximum. I mean, no absolute maximum. This is local, but there are y values that are higher. So on number 7, there were different versions, but one of them was there is no absolute max, or there was no absolute minimum, because it was an open thing. And the most missed point, 6a. A lot of you got, hey, inside the squishy middle, there's a maximum because the first derivative went from positive to negative. Yes, and you needed to look at the endpoints. If the velocity or the first derivative was positive until the end, life was all up and rosy till the end, that would have been a maximum. Or if from the start, if that's my first derivative was positive, so from the start, things were going up from there, that left endpoint would have been a local minimum. So you needed to check the ends as well. All right, guys, see you later.